Okay, so we're going to talk about how to solve series circuits, and then the next video will be paralleled, and we'll talk about a compound, which is a combination of series and parallel. A couple of things you need to remember about series circuits is that the total resistance is just the sum of all the resistances. The electrons have to go through every resistor, so you just simply add up the resistance. I have a bunch of questions off to the right here. You can search for what's the current passing through each and every resistor, what's the total current in the system, what's the voltage across each. Remember, if you were to put a voltmeter in there, you measure across, and what is the total or equivalent resistance in the whole circuit. You may not be able to answer these questions in this order, but you can try to find the one that you can answer with the information you have on hand, and then use that to solve the other problems. All right, and remember, we have Ohm's law. The current is equal to voltage over resistance. And we know that for series circuits, current is the same everywhere. And it's for series circuits, voltage is shared. But here, what we need to look for, one of the big things is the total resistance. We know the total voltage is 12 volts. If we can find the total resistance, then we can find the total current in the system. Well, so as far as equivalent or total resistance, what that means is in this case, the battery doesn't know it has 3 resistors. It has 12 volts, and that flow that the electrons it's trying to push through are being resisted. And what we're going to do is find the equivalent resistance of these 3 as if they were all just one single resistor. And well, okay, so for series circuits, we know that it's just the sum total. So we have 4 plus 3 plus 2. So we know we have 9 ohms of total resistance in this circuit. Now to find the total current, well, we know the total, the voltage total. We know the resistance total. So the current is just voltage over resistance. So it's 12 volts over 9 ohms, or 1.33 repeating amps. Okay, so traveling through the system here, 1.33 amps. Well, remember, for a series circuit, the current must pass through everything. It has no choice. There's no other branches for the electrons to pass through. So whatever the current is in the system, it's the same everywhere. So I know at resistor 1, the current is 1.33 amps. And at resistor 2, and at resistor 3. It's the same everywhere. Okay. Now we're down to just one more question. What's the voltage across each resistor? It's still going to be Ohm's law. Current is voltage over resistance, but we're going to solve it for voltage. So voltage is current times resistance. Remember, the current is the same everywhere. So for resistor 1, it's 1.33 amps times 4. So if you get out your calculator, it's 5.33 volts. And we'll do the same thing. Voltage is still going to be IR, but for resistor 2, it's still 1.33 amps, but it's times only 3 ohms. So that is 4 volts. For resistor 3, it's still current through the resistor times the resistance, so 2.66 volts. That's the basic way you solve series circuits.